two programming categories in the lab program. Okay, so one is using the concept of basic mathematics. Okay, so for the decision tree algorithm, whereas the other one is the using pandas library. Okay, so let us go with the first one using the normal general basic method. So first we need to import the mathematical library using math, and then I need to load the CSV file. So for that purpose, I'm importing the CSV commands. Okay, so then I will be writing a load CSV function. Okay, so and it reads the file, and this file should be present in the folder where you are executing the code. Okay, so that is what is written here. Define is a function load CSV. So once the file is being loaded, I need to read the total number of lines that has been present in this file. So how to read that? I'm taking a variable line. I'm reading the CSV dot head reader open file name. What's the file name? The file name is written here. Okay, it is ID3.csv. Okay, in that file we have written all the content dataset instances which is present, which we have discussed in the last class. 14 dataset instances. Okay. So that is for general. Then I have written another test file or written a CSV file for testing purpose. Okay, if I give the data set in a random way without having the label content, so it should predict whether the person can play the template game play tennis or not. Okay, I have given only two cases here in the test case. Okay, so next once the file is read, have read the dataset instances, then what I will do, I will make those lines as a list. Okay, so you know the list concept. It takes as an array and it stores in the file is in the form of index array. Okay, and I will take just data as a data set. Then what I will do, I will make the header. I need to find out the header, right? So what I will make the data set is a pop function. What does a pop function does? It gives the output of the last one. So it makes or it considers that variable or the that attribute as a header file. Okay, so then it returns the data set which along with header. Okay. So next, shall I go and directly explain the main function part, or do you want to explain, or do you need the explanation of all the functions? Because I think let us go from the main function itself. Okay. So the main program is written here. So what is it states? So data set and features I need to extract. So I'll be reading the CSV file. Once this is done, what I will do, I want to create a node, right? So because I need to find out the root node. So for that purpose, I'm going to build the tree. This is a function, build tree of dataset comma features. Whatever the values I get, for that I need to build the tree. So when this function is called, so this function gets executed. This is a function call. So when this is dead, so what I need to do, I need to get the last column values, because there I will be getting the variable values or some attribute values. So for that I need to find out the last column. So last column is equal to row of -1. So what it gives? It gives the last value in the row for row in data. Then I will check the if last length of the column's last column or using the set command, if it is equal to 1. If it's equal to 1, then I will make it as node as empty or it. Okay, so that means I need not to evaluate the node. Suppose if this condition becomes false, then I need to get the last column value. So the last column 0 means the first value of the attribute is considered as an input or the node. So that will be considered as a node for answer. Then I will return that node. Okay. Next, what I should do after this, I need to get the total number of attributes, right? So for this, I will be taking n is equal to length of data of 0 minus 1. So data of 0 gives the total number of elements or attributes minus 1, and it gives the total number of attributes that are present in the data set. So what I should do then, once I get this is your entropy value, we are going to consider for entropy purpose. Okay. Next, I need to find out the information gain. So for that, I have written the variable gain equal to, I need to, initially it will be in the form of null data set, because no value is being gained right now, because I have not evaluated any features. So next, once it is done, I need to check for each column in range of n for the length. If gain of column is equal to compute gain of data comma column or column. Okay. So compute gain is a function. So what it does, it goes to this function compute gain. So there I will be reading the attributes, and I am going to make it as a dictionary one here. So for that purpose, I need to generate a separate table or values where I need to read the data, right? For that purpose, I'll be taking a concept of subtable here. Okay, the given data table, I will divide it into subtables. So subtables will be taking the data along with the column, and in the condition like this delete is equal to false. Why we have taken the delete equals to false means if any one of the value or the attribute is mismatch or it is not considered as a primary attribute, then at that time I need to discard it. Okay. So once it is done, I need to find out the total size of the given data set. That will be is nothing but length of the data becomes the total size. Next, I need to find out the entropy. Entropy is equal to 0 into length of attribute initially. Next, this is your ratio. That is nothing but your probability values which you are considering. So it's 0 into length of attribute. Initially, these value entropy and probability ratio will be 0, empty. Okay. Next, once it is done, I need to find out the entropy for each attribute. So total entropy equal to entropy of row minus 1. So this is the last row value for the data, and it checks the condition for the iteration part. So I need to read all the data up to the end of the row for each column value, for all the columns by considering any one attribute. Okay. So for that purpose, what it will do for x in range length of attribute. So ratio of x is proportion probability ratio equal to length of dictionary of the attribute of x. Okay, what are the attribute of x? Suppose in our example, we have to consider it as wind. So if I take the attribute as wind divided by total size into 1. Why we have? Because 1 means the value of the entropy will be made as 1 here. Because I need to, if I give the value as 0 here, this becomes divided by 0 constant. Okay. So the value becomes infinity. So what I should do? I should multiply it by 1. So anyway, in the value which comes here, it is multiplied by 1, it gives the same value. Okay. So once it is done, entropy of x becomes entropy of row minus 1 for row in dictionary. So I will be storing the data in the dictionary, right? So for those attributes, I will be considering the value of entropy. For that each feature, I need to find out the total entropy equal to, and we have written as a function here as a shorthand assignment. So why it has taken total entropy minus means we need to write the function in the form of minus ratio into entropy, right? So that is nothing but your minus p plus into logarithmic value. So once it is called, I will be getting the total entropy, and this function here I have written entropy, right? So this is a function. Okay. So once it is called, it will be called back over here when this is being called. So what does this entropy will do? Entropy takes the data set as attributes. It checks whether the length of attribute is equal to 1. If it is equal to 1, then it returns null. That means there is no other feature. So make that feature as a root node. If it is not equal to 1, we are going to set a counter variable 0, 0 for checking the row and column values. So it checks for the range of 2. So range of 2 means it will be considered 0 and 1. So for I equal to 0, what will be the value of counter I? So it becomes sum of 1 for x. So it will check the iteration and divide by length of the attributes into 1. Okay. Next, once it is done, I need to find out why we have taken this one. This is first part of the probability function, what we have discussed, like minus 6 by 9, like that example. So that will be called here. Once it is done, I will initiate the sum variable as 0. Then I will check the count. I need to multiply it by log 2, right? So for that purpose, I will be taking another variable count in count. So sum plus is equal to minus 1 into count into math.log. So this will be your mathematical log function. And what is the base value? I need to take the count with respect to the base 2. So this function iterates for each attribute and returns the sum value for that particular attribute. Okay. Once this is done, so this function iterates till all the row values and for all the column values here. Okay. Then I will be getting the total entropy for the overall data set. Once it is done, I'll be going back to the main function. So that function will be made as node 1. Okay. Now, once this is done, I need to take that, or I need to build the tree. So for that, what I should do, I should get the node, right? So the node will be written here. The build node, what we have discussed. So compute gain is done. Now once this is done, I need to go for the splitting part. Why the splitting part takes place? Because that attribute becomes the main root node. For the remaining attributes, I need to divide the tree. So for that, I am going to call the function split. So gain.index becomes the maximum number of gain. So the value which comes as the higher value for each attribute. So that attribute I need to make it as the splitting attribute. So hence I have taken maximum gain here. Okay. So then once it is done, I will be taking the similarly whatever we have done here, this concept will be iterated from the first part. Okay. Once it is done, suppose there are 4 features. One feature is already been made as good. So for that, we'll be having 3 possible values. Like for the, if you have considered as outlook feature, we have 3 possible values. So now if I discard that outlook, remaining features I need to consider. So for that, I need to find out the feature part. So the feature part will be given by feature into colon split. So what it does, it takes all the initial starting values and it excludes the split value. That is the one which I have taken here. It discards it and then it adds with the feature plus 1 here. So initial, that means it's going to consider where we need to add that feature. We need to add that feature to the root node plus 1. So that will be the sub column or the subtree of the data set. Okay. Once this is done, after this, I will be taking those attributes and dictionaries and I will call the function here. Earlier we had written subtable here in the gain as false, right? Because we didn't know. Now we are known, we know the data concept very well, and we have calculated the information gain and the entropy for all the attributes. Okay. Now what it will do, I have got the data in the true condition. So what I make this column. So subtable of data split, data and splitting part delete equal to true. So the subtable we have written another function here, which we are discussed right now. So the subtable, what it does, it takes the dictionary as empty in the initial. It takes only the column value for calculation purpose, and it considers those as a list part, and it multiplies by count, and it evaluates the length of the R and C. Okay. Now once it is done, so what I should check? I should check the attributes, whether the length of the attribute is exceeding the limit. So for that, I am going to check this condition. If data of the particular attribute into column, if it's equal to attribute of x. If it satisfies this condition, I need to increment my count. If it doesn't satisfy, then this coding part gets skipped. So once it is skipped, it comes over here for calculating the dictionary part. That is, list is already stored and initially it is 0 and it counts the value. For finding the position, I'm going to consider it as 0 because I need to find out whether it has to be placed in the left hand side or in the right hand side. Okay. So I need to find out the position. So it's going to check whether the data of the particular attribute into column equal to attribute value. If it is true, go for delete purpose. That means it has been satisfied. So delete that particular data along with attribute and column data. Once it is done, it's going to check the position of that value and it increments the position where it has to be placed and returns the attributes along with dictionary data. Okay. And once it is done, here this condition has been executed. So it checks whether this attribute becomes a child node or the parent node. So because already we have calculated the parent node, so what happens? The next condition will the node will be the child part. So it checks for the range of the length of the attribute and it builds the tree along with the dictionary of attributes along with features. So overall remaining attributes along with the remaining features. Once it is done, it's going to consider those as child, and we are going to append that child node with the parent node as node.children.append to the respective attributes. Okay, it returns the node. Once this is done, so I have got the node, parent node, and child node and all. Now what I should do? I should make or print the tree. So for that, we have taken the printing tree as node 1 equal to 0. Okay, so node 1 gives the root node, and it's going to check for the initial state. It's a 0th row or the 0th root. Next, we are going to check for the remaining other data set, right? So for that purpose, what I should do, once the concept of build tree has been done by computing the gains and by computing the entropy, what I should do, and by knowing the subtable data, now what I should do, I need to make this node as self attribute because I don't know what data can be inserted at a particular node. So I will make that node as self. Okay, for all the attributes along with children for all the answers. Okay, once these conditions have been done and the tree concept has been built, what I should do, I should go for the printing of the tree. So it checks for the condition if the node dot answer not equal to null. If it is null, take the node, whatever the node we get, make it as root. If it is not equal to null, so print take the value, attach the node with the attribute, and check the condition for each value. And once it is done, I need to increment the level of the value. So it will be done by level plus 1. Okay. So classification will be done by like this. So it's going to check the node. Why we have taken classification means there we are testing the feature. It is not yet there in your lab program, but we need to do that first because so that we will get the classification. So it checks for the node and the testing data set. If checks for the null data set, if it is there, make it as node as root or answer. If it is not, find out the features, index as source data set, and similar iteration takes place for the process here. For each value, n in node, it tests the values of the attributes along with the position, and it verifies with the value. If it is equal to true, it classifies the data. Okay, this is what it is written here. So for testing data, we have taken ID3 test1.csv, and to print the data, we have taken here. Okay, so I will execute this code. So this is your output. That's it. This is output. Okay. Any doubt in this? So you can see here, we have considered the outlook as my base attribute. So for the outlook, which is the most prominent data, the overcast. Sorry, outlook is the main primitive. In that, we had already got the data for overcast as yes, because it is the only positive cases. So it directly divides the data. Next, it checks for the rain condition. Whereas you see here, in this example, it is not represented in the form of tree. Okay, it is represented in the form of tree, but in the order here. Okay. If in the rain case, we need to consider the wind. If it is weak, he cannot play. If it is, he can play. If the wind is strong, he cannot play. Suppose if I take the attribute as sunny, so based on humidity, if it is normal, he can play. If it is high, he cannot play. So the test instance of what I have taken was, I had considered the rain as my primitive attribute, and I have given the temperature as, humidity as cool, and wind as normal, and the attribute as strong. So if this is the case, the label will be made as no, because the player cannot play the game in this condition. Suppose if I take sunny and the test case as mild, normal, and strong, then he can play because the attribute this is the most prominent attribute, right? So he can execute. So this is your first type of program for the lab 3 using general mathematics. Okay. So this is your second part. So this is where you can let me restart the kernel. Okay. So this is where you are going to use pandas library. This is very short program. Okay. But the output is very lengthy. You can see the output. When I execute it, the output starts from here. By reading the data set, that is your 14 data set rows along with the training value or target attribute values. Okay. And it checks whether the total number of instances is positive and total number of instances is negative. I think this is best because we have done the lab program, but this cannot be executed done for all the data sets. Okay. Because it is made of specific. Whereas earlier code is made of general code. Okay. So entropy will be calculated. This is what the value we had got in the lab, in the programming theory class which we have done. Okay. So this thing will be here. Why this data is being made as generated means for each attribute I need to find out the gain, right? For that, which are the conditions I need to consider, or which are the data set that I need to take for the calculation part. Those data will be made as output in these cases. Okay. So you can see here, you can get the value. How many number of yes is there, how many number of no cases for particular attribute. Okay. And what was the information gain for humidity when these cases are taken for normal, and what is it overall gain for humidity. Okay. So this process it takes place for all the categories. So this is for humidity. Similarly, we have temperature, and for humidity, then at last we have for wind. Okay. And I have sent the problematic answer in the Google Classroom where you can see the problematic steps where we have done this. Okay. So those data have been executed in the same way. Whereas here, the decision tree is represented like this, like in the form of dictionary. Okay, it's going to take the most prominent attribute for division of the decision tree or deciding the root node. So it checks the overcast is yes, so it is true. So no need of dividing it. So this becomes one data. So if I take the Sunny as my attribute in the Outlook feature, so there I need to take, that means in the left hand side I need to have humidity. So that is what I today in the previous class I have entered. If it is raining, this type of data because in the wind we have two cases, strong and weak. If it is strong, no condition. That means we will have only negative example. If it is weak, we have only positive example. That means you can enjoy and play the game. Whereas in this Sunny case, we have humidity high. So if it is high, you cannot play the game. If it is normal, you can play the game. Okay. So that is what is explained here. We are going to import Panda libraries. So I'm going to read the CSV file. I'm defining the data frames of those CSV file and I'm to take it as tennis, defining the tennis. So I'm going to print that values which we did here. So it takes this concept, this part. Okay. Next, once it is done, the main file is over here. Next, what I need to, once the data has been selected, how many total number of data instances are there, I need to calculate the entropy for each attribute. So I'm going to write a function for entropy, define entropy of probability, import map, return sum equal to, I'm directly calling the mathematical function. For each attribute, it's going to apply log2 for the probabilities using the map. Okay. Next, once it is done, I need to take those entropies and make it as a list. Because why I need to make a list means because I need to check for each attribute, right? So for that purpose, I'm doing this. Okay. So Jyoti,
Yes, sir.
what this code explains this part. The highlighted part, what it does.
List of attributes.
Yeah, it makes the attributes as a list. But we have taken the concept of counter here. Why we have taken counter? Rachana, Sahil, Mukta, Mega, Akhilesh,
ಸರ್
ಏನ್ ಮಾಡತ್ತಪ್ಪ?
ಸರ್ ಅದು ನಂಬರ್ ಆಫ್ ಎಸ್ ಅಂಡ್ ನೋ ಕೌಂಟ್ ಮಾಡೋದಕ್ಕೆ ಕೌಂಟರ್.
Yes. So here this counter will be taken for to answer ಇಲ್ಲೇ ಇದೆ. No and yes classes ನ prediction ಮಾಡೋದಕ್ಕೆ I am considering the count part. So to do that counting part, I need to read that data, right? So what I have done, I have taken the functions of importing the counter from the collection. Okay. So once I get that data, I'm going to take the list which you have already generated, and make this data as each count here. So it takes whether the total number of no and yes classes, and it prints. And to get the total number of instances present in the data set, it checks the length of the list, okay, and it will be multiplied by 1. Why means the entropy in the initial part, it should be 1. Okay. Next, probability of each data becomes the formula which we have discussed in the last class. So value of the attribute divided by total number of instances. Like if I'm having 6 categories and total 9 positive cases out of 14, so the probability will be 9 by 14. Okay, and it returns the entropy of the particular probability. Once it is done, I'm going to take the game as a play tennis game. I'll be finding the total entropy using this concept through the list. Once it is done, I need to find out the gain. Because in the entropy part, we'll be getting only the data set of a particular value of each attribute. Okay, I need to find out all the values for each attribute. I need to calculate the entropy. Once this is done, I need to take those data to find out the gain. So to find out the gain, what are the data I need to read? I need to read the data set or the data frames. DF stands for data frames here. Okay, that is what we are going to read. And what are the number of attributes I need to split it up? And what is my target attribute name? So these three are and one more thing, I need to have a value called trace. In the initial trace is 0 because I have not at all generated the data. So the initially it will be made as 0. Now, once I got this data, so what I should do? So I'm going to take which is the attribute I'm going to split. Okay. So that is what it is written here. Take a data frame of attributes and quantify the entropy of the target attribute after performing the splitting part. Okay. Once this is done, I have got the split attribute. So what I will do, I will make those attributes as group by function for calculation of the split for the data. Once this is done, I'm going to print those names and print the particular group where it belongs. So next, once it is done, I'm going to calculate the total number of knobs. What are knobs? So knobs is nothing but once the data has been generated for the splitting node of the data set has been done, I need to categorize only the data sets where I need to find out the remaining total number of attributes, remaining one. So for that we have taken. So for that we need to calculate the aggregate entropy by calling the function split dot aggregate into entropy of list divided by the lambda function. So you know the lambda function how it works. Okay. So I'll be taking the attribute length of the node divided by total number of knob value into target attribute name. Okay. Once this is done, I'm going to read the column data to check whether this data is to be calculated or not. Once this is done, if it is getting new data, then I'll be calculating the new entropy because the earlier entropy may not be considered as the important one. So for that, I'll be reading this. Okay. And if this is not at all generated, then this old entropy will be evaluated. Once this is done, I need to get the information by subtracting it. So old entropy minus new entropy. This gives the value. That is what is going to print here. Information gain for outlook is humidity, for wind, for temperature. We have written all the cases by reading as a string, and it is going to read the function by considering the respective attribute values. So this is the specific part where the code is being written. Okay. For this particular data set. So this is your ID3 algorithm. So counter, we are going to create the attribute name, check the condition. If it is not, return default value. So that we are discussing the last, so the same thing is written. Okay. Any doubt in this? So that's your explanation for the lab 3 program. Okay. I want you to look into this code, okay, because this is made up specific. If you feel that you can learn only for this, then study this part.